Chapter 14, sample problem number 12. A pipe of length 80 centimeters is open at one end and closed at the other. Let's get our important things here. Open at one end, closed at the other. Sound is created in the pipe at 4 different frequencies. The diagram shows the location of nodes and antinodes in the pipe for the 4 different modes. The table to the right has an entry for wave speed of the second overtone. And we'd like to figure out complete the table of frequencies, wavelengths, and wave speeds and explain our reasoning. Before we dive into anything, I'm going to find what modes we're in so that we can use that in our formulas later. So for an open-closed pipe, the fundamental, it has to be a node going to an antinode. So that's this guy. So this is n equals 1. And then here we have 1, 2, and 3 modes. Those are 3 copies of the fundamental, which is 3. Because remember, the fundamental is from an antinode to a node, or vice versa. And then here we have 1, 2, 3, but also 4, 5. And then here we have 1, 2, 3, 4, but also 5, 6, 7. So not surprisingly, we get the odd modes. And that will be useful in a bit. The other thing we want to remember is that F1, the fundamental frequency for an open-closed pipe, is the wave speed over 4 times the length. So we'll need to make sure we have the wave speeds, but that's almost a trick question because the wave speed for air is frequency independent. Air is non-dispersive, meaning that the wave speed is the same for all of them. So we'll just put that in right away. That lets me go down here and say that the fundamental frequency would be 340 meters per second over 4 times. Now, to be careful because we have centimeters, but we need to be in meters if we want it to be the same as our velocity. And so this turns out to be 106.25 hertz, which is, with our precision, 106. And then all the others are nice because any other mode is just the mode number times the fundamental. So for instance, F3 is 3 times F1, which is something like 318. And then F5 will be 5 times F1. And we probably should use the 106 1/4 because we should round off towards the end. So 106.25 times 5 is 531.25. So we can call this 531. And then finally, F7 is going to be 7 times F1. 7 times 106.25 is 74375. So we should say 744 as our. And then it becomes really very simple because after that we're just going to say, oh wait, for any wave, the velocity is the wavelength over the period, which is the same as the wavelength times the frequency. So the wavelength is just the velocity over the frequency, and I can just put that in each case. So I can say 340 over 106, and I get 3.21, or 340 over 318, and I get 1.07, 340 over 531, and I get 0.64, and 340 over 744 is 0.46. In meters, since we were already in meters, we have something like that. Probably should carry an extra digit, so it really should be 5.456. For these last two, I should have 3 digits, so it should be really 0.456 and 640 to proper significance.